Almost every week a natural disaster happens somewhere around the world. We often watch them unfold live on the news, when forests go up in flames, when settlements collapse after an earthquake, and roads and bridges are torn away by landslides, when volcanoes erupt or severe floods wash away our communities under torrents of water. When major disasters threaten, the lives of thousands can be put at risk. Time is of the essence, and rapid, accurate data can be crucial, particularly if search and rescue teams have to access very remote terrain. Today, satellites are some of the most helpful observers on our planet. From orbit, they can see through the clouds, detect storms and fires, and even reveal the slightest movement in the Earth's crust, literally anywhere in the world. However, satellites are always moving. They pass over a region affected by a disaster for only a few seconds, and return anywhere from hours to days later. It is unlikely that a single satellite would be in place to witness a disaster when it happens. But there are many satellites circling our planet, each on a different track and capturing different views of our Earth. The chance of getting the perfect picture of the disaster zone is much higher if rescue teams can combine all of these views and pick the best of them. This is the idea behind the International Charter Space and Major Disasters, founded in the year 2000 by the European, French and Canadian space agencies, providing the best available satellite pictures to help with disaster relief and recovery anywhere in the world, and doing it without expecting anything in return. Today, more countries from all around the world have chosen to commit their satellites to help provide the information necessary to understand the impact of major disasters, what has happened, who has been affected, and how to respond effectively. And every country in the world can access this information through the universal access the International Charter offers. An earthquake in Asia. One satellite has provided a high-resolution image of the area before, and another satellite passes over just after the tremor. The images show where homes and villages have collapsed and where roads have been blocked by landslides. Rescue teams have up-to-date information in hours, helping them decide how to access the affected area and where they can do the most good. A volcanic eruption in Africa. Special satellites are configured to observe the lava, smoke and dust, and to deliver high-resolution maps of the affected communities. Experts can accurately assess whom to evacuate and where to establish a safe refugee camp. Flooding in Europe. A satellite gauges the amount of rainfall, while another measures the rising water level through the clouds. Yet another satellite delivers the latest map of affected areas, while others track the next storm brewing over the horizon. Citizens can be warned, trains stopped, roads closed, dams fortified, to help manage the worst of the water. We cannot prevent natural disasters from happening, but we can help to manage their consequences. Satellites provide rapid, accurate information anywhere around the world, 24 hours a day. The International Charter Space and Major Disasters is helping to save lives wherever disasters strike.
Will I see myself when I appear though? Okay, cool. Okay, welcome to the last session of the morning. We're talking about protecting through space. This can be things like monitoring natural disasters from space and saving lives in extreme situations. And I'm going to be joined today by a couple of guests to talk a bit more about this. But before we start, a quick reminder, if you'd like to ask any questions, pop them in the question box that you can see on the right-hand side of the screen. Our hashtag today is POP23. And all of our sessions are being recorded. So if you missed something from earlier and you'd really like to catch up, maybe you missed me shivering in front of an iceberg or the rainforest section, please do catch up later. The sessions will be made available to you. Before we get started though, I'd just like to quickly introduce who I'm going to be speaking to. So there's a couple of people who are going to be joining me today. Philippe Bally, Earth Observation Applications and Satellite Specialist from the European Space Agency. And we've heard so many mentions of the European Space Agency today. It's going to be a great pleasure to have a chat with Philippe. And also Zachary Foltz, an Environmental Research Engineer from Argans Limited. And they're going to be talking a little bit about the International Charter, looking at space and major disasters. Are you there, Philippe and Zachary? Oh, I can see you, but
Hi.
can you hear me?
Hello, yes, we're here.
Okay, great. All right,
Yes.
well, Over to you in that case. Oh, can they hear me? There we go.
Hello, everyone. I'm Zach Foltz from Argans Limited in France, and we're a remote sensing company that's supporting ESA with the initiative of the International Charter Space and Major Disasters.
I am Philippe Bally from the European Space Agency, and the European Space Agency is one of the members of the International Charter and is also one of the founders of the International Charter. It was set up in year 2000, and ESA was one of the organizers of this initiative.
Okay, I'm not sure if you can hear me. Zachary, would you like to just present an introduction to what we're talking about today, the Charter itself?
Sure. The Charter is an international agreement between 17 space agencies from around the world, and the Charter is focused on natural disaster response. So when a natural disaster happens around the world, the country where the disaster happens can request satellite data from the Charter. And if the country is not a member of the Charter, then cooperating bodies such as the United Nations can send this request. So we've had over 850 activations over the last 23 years in the Charter in over 130 countries. And we're going to show a video in just a second to explain a little bit more about the Charter.
Okay, great. Yeah, let's cut to that video. Oh, maybe we don't have your video. Are we struggling? Ah, here we are.
Almost every week, a natural disaster happens somewhere around the world. We often watch them unfold live on the news, when forests go up in flames, when settlements collapse after an earthquake, and roads and bridges are torn away by landslides, when volcanoes erupt or severe floods wash away our communities under torrents of water. When major disasters threaten, the lives of thousands can be put at risk. Time is of the essence, and rapid, accurate data can be crucial, particularly if search and rescue teams have to access very remote terrain. Today, satellites are some of the most helpful observers on our planet. From orbit, they can see through the clouds, detect storms and fires, and even reveal the slightest movement in the Earth's crust, literally anywhere in the world. However, satellites are always moving. They pass over a region affected by a disaster for only a few seconds and return anywhere from hours to days later. It is unlikely that a single satellite would be in place to witness a disaster when it happens. But there are many satellites circling our planet, each on a different track and capturing different views of our Earth. The chance of getting the perfect picture of the disaster zone is much higher if rescue teams can combine all of these views and pick the best of them. This is the idea behind the International Charter Space and Major Disasters, founded in the year 2000 by the European, French and Canadian space agencies, providing the best available satellite pictures to help with disaster relief and recovery anywhere in the world, and doing it without expecting anything in return. Today, more countries from all around the world have chosen to commit their satellites to help provide the information necessary to understand the impact of major disasters, what has happened, who has been affected, and how to respond effectively. And every country in the world can access this information through the universal access the International Charter offers. An earthquake in Asia. One satellite has provided a high-resolution image of the area before, and another satellite passes over just after the tremor. The images show where homes and villages have collapsed and where roads have been blocked by landslides. Rescue teams have up-to-date information in hours, helping them decide how to access the affected area and where they can do the most good. A volcanic eruption in Africa. Special satellites are configured to observe the lava, smoke and dust, and to deliver high-resolution maps of the affected communities. Experts can accurately assess whom to evacuate and where to establish a safe refugee camp. Flooding in Europe. A satellite gauges the amount of rainfall, while another measures the rising water level through the clouds. Yet another satellite delivers the latest map of affected areas, while others track the next storm brewing over the horizon. Citizens can be warned, trains stopped, roads closed, dams fortified to help manage the worst of the water. We cannot prevent natural disasters from happening, but we can help to manage their consequences. Satellites provide rapid, accurate information anywhere around the world 24 hours a day. The International Charter, Space and Major Disasters is helping to save lives wherever disasters strike.
Good, well that was a great introduction. I'm going to hand over to you two to have a chat a little bit more about the Charter, and then I'll come back at the end with any questions that we've had come in from the audience.
All right, great. So we'll now show a presentation that just shows some examples of the Charter in action and some satellite data that's been collected by the Charter. So I'll share my screen now. All right. So as I mentioned before, the Charter is an international agreement between satellite operators to provide priority access to satellite data in the event of major disasters. Again, we're focused only on disaster response. Satellites can be used for all phases of the disaster management cycle. However, the Charter itself is just focused on the response to natural disasters. So these are the Charter members. We currently have 17 members of the International Charter and 4 of the 7 continents around the world. And members can be any space agency that owns or operates a satellite. We just ask that they have at least one satellite to contribute to the Charter. So the types of disasters covered by the Charter, it's both natural and man-made events. This can be earthquakes, fires, floods, landslides, any types of storms, as well as volcanic eruptions and snow hazards. Also, man-made events such as oil spills and industrial accidents can be covered by the Charter. And we do want to mention the Charter cannot be activated for things like war or armed conflicts, or also slow onset disasters such as droughts, as these disasters take a long time to process and we're just focused on immediate response. So these are the activations by disaster type over the course of the history of the Charter. As you can see, floods and storms are covering the most of the highest percentage of disasters, and these are the most common disasters around the world. So climate change is affecting the frequency and severity of disasters, increasing the frequency and severity of natural disasters. But this occurs in different ways depending on the disaster type. With flooding, things like deforestation, urbanization, changes in land use can exacerbate the impact. If you think about trees being removed from a certain area, then these trees are not going to be able to absorb the water that is coming from a storm or other flooding event. As I mentioned before, with storms, climate change is altering the weather patterns around the world, and this is producing more frequent and severe storms. For fires, warmer, drier weather can increase the extent and duration of forest fires. And as for geohazards, such as volcanoes and earthquakes, these are driven by very complex geological processes, and therefore the extent to which they're affected by climate change is unclear at this moment. However, there are still a lot of earthquakes and volcanoes occurring around the world. This is a map of all the Charter activations in the Charter's history. So if you look at the legend on the bottom, the light blue dots, these are cyclones. So these can be seen around the Gulf of Mexico and Caribbean area, as well as in Southeast Asia, where they have monsoon seasons and things like that. The yellow dots are for earthquakes. So these are mostly seen in South Central Asia and the Middle East, as well as Southeast Asia as well. For fires, these can occur anywhere where there's a heavily forested area, but mostly in Canada and the Western United States, as well as Southern Europe. Floods, of course, these are happening all around the world. Definitely a lot of floods in Western, Central Africa, Southeast Asia, and South America. And as for the other disasters, they're pretty evenly spread. So taking a step back from the charter itself and now explaining how satellites can help manage disaster events. So there are two main types of satellite data that are used. The first is optical data, and this is the one that most people are familiar with, as this is essentially just a photograph taken with a very powerful camera from a satellite that is orbiting in space. And these images can be affected by cloud cover, and they're reliant on the sun to produce light. So when you open up Google Earth and you look at Google Earth, this is a collection of cloud-free satellite imagery from all around the world that is taken at different times. The second type is that you may not be as familiar with is radar imagery. Radar imagery is taken from a satellite that's equipped with a radar sensor, and this is sending a microwave signal down to Earth and is recording the energy that is reflected back to the sensor in space. So these sensors can see through the clouds, and also they are not reliant on the sun to produce light. So as you can see here in the two images at the bottom, these are over the same area. This is a flood in Honduras. As you can see on the left, you can still see the flooded area, definitely, but the clouds are affecting the view of the image. And on the right, the radar image, the darker areas, you can see the river here coming through the middle. And the reason the water is appearing dark is that the water is absorbing a lot of the microwave signal from the satellite and is not allowing it to be reflected back to the satellite. So the satellite is collecting this data and it is representing the water as dark. So now we'll take a look at a few examples from different disasters that the charter has covered. This first disaster is a recent one. You may have seen it on the news. It is a flood in Libya. On the left, you can see the image before the event, and on the right, the image after the event. And I'd like to bring special attention to this red circle here. The main cause of this flood was a break in this dam here. So on the left side, you can see that there's water behind this dam, and on the right, you can see that the dam has been demolished and the water has been allowed to freely flow through, and this has led to a lot of destruction along the course of this river. Now here's a little bit more zoomed in image, animation of the before and after image. And you can see that this dam break has caused all 5 of these bridges that were crossing the river to be destroyed. So now we'll take a look at analysis of flooding with radar data. This is some data over Scotland, just south of Cairngorms National Park, which some of y'all might be familiar with. This image was taken by the Sentinel-1 radar satellite from the European Space Agency. It's one of the most used radar satellites in the world, especially for disasters. And as I mentioned earlier, the water is absorbing most of these microwaves. So when there is a water in areas where it was not previously, you can see in the animation that now there is many dark areas around the image, and this is representing the flooded area. Now taking a look at how optical imagery can be used for earthquake damage assessment. This was some images over Turkey during the famous earthquake this February. On the left, you can see the pre-event, and on the right, the post-event. And on the right, you can see there's some damage here on the surface, and the image below is showing this is an image from a news article, and it is showing this area after the event. So with these high resolution optical satellites, it is possible to locate damage across a wide area. Now looking at optical imagery for landslide analysis. This was a landslide in Colombia. So again, I have the animation here on the left showing the before and after images. And on the right here, we can see how we can trace the outline of the landslide, and in this way we can see how much area has been affected by the landslide. So here, just under 75 hectares of area was affected by the landslide. Now optical imagery for fires for assessment of the burnt area. This was just this past summer in British Columbia, where there was a very strong and long fire season caused by some drier and warmer weather. So as you can see in the after image, there's a large portion of the area that has now turned brown. And this is how satellite data is very useful for assessing the extent of the burnt area across a wide area of forested area. Now taking a look at active fire monitoring. So satellites are able to identify hotspots. So a hotspot is an area of fire that is currently burning. So these are two different images over Chile. These were fires from just earlier this year. So the red areas you see in the photos are areas where the satellite has identified uh, that the area is still burning. So these types of maps can be used by the fire brigade to monitor the progression of fires without necessarily putting themselves in danger in certain areas. So they know how the fire is progressing, where it's moving, and they can organize their resources to stop and slow down the effect of the fire. So now that we've seen all of these satellite images, how can these actually help with the disaster response? So satellites provide near real-time data. There's only an hour to a couple of hours delay between the time the satellite is acquiring the image and the time the scientists are able to analyze the image. So this is going to help identify the affected areas and prioritize the response effort overall. So after a bit of analysis by the scientists, you can now evaluate the severity of the destruction, identify some critical infrastructure damage like bridges, buildings, things of this nature, and you can now prioritize areas that require immediate attention for search and rescue. So in the event of an earthquake, if there is a large area of rubble, which is not allowing the the rescue teams to enter, this can help identify where certain resources need to be applied to be able to respond to the disaster and save as many lives as possible in the end. So finally, I'll give a take-home message. The Charter is a philanthropic best effort organization. There's no money involved in the Charter. It is all through the agreement by the space agencies, and each space agency has certain representatives that are working on the Charter project, and this is a long-term commitment from the space agencies. So every space agency is contributing in a certain way. They're supplying their data, they're supplying their human resources as well. So the Charter is used by relief teams to better understand the situation, to save time, and to use the resources effectively. Like I mentioned at the beginning, the Charter is only for the immediate response for a disaster, but satellite data can be used for all phases of the disaster management cycle. For example, ESA has collaborated with the World Bank with the Global Development Initiative, and this is using satellite products to better understand natural disasters, when they happen, how they happen, and this can help with the prevention, early warning, and as well the recovery, long-term recovery after a natural or man-made disaster is occurring. So that's all we have for the presentation. Now we can take some questions.
One thing that's cropped up quite a lot of times in the questions that I've seen come through so far are things like, if something goes wrong with your satellites, can you fix them or are they done for? And if they are done for, what does the end of life look like? I think a lot of our students are very aware of space debris and the problem of leaving satellites up in space. Maybe one of you might be able to elaborate a bit on what happens at the end of one of these satellites' lifetimes. Either one?
Well, this is Philippe Bally from the European Space Agency. Can you hear me?
Yes, I can hear you. Go ahead.
Yes, okay, yes, sure. This international charter is an international collaboration that is a virtual constellation. It doesn't own satellites.
Okay.
It's all brought as a best effort contribution by space agencies. Each space agency is responsible for the operations, exploitation of their mission. And when the mission has reached the end of life, you have what we call the heritage mission, because we still work with the archive of data that were acquired by the satellite. And at the end of the lifetime, when the satellite has ceased to operate, then we have some scenario to maneuver the satellite and make sure it doesn't make debris. Each agency have their own policy or method or procedure to do that. At ESA, we have rules that are quite strict on the principle of not augmenting the quantity of debris in space, and we have a certain way to do that to make sure that we do the minimum amount of debris with the satellite. Typically, you lower the altitude of the satellite and then it burns into the atmosphere and it's disaggregated and it disappears.
Fantastic. So thank you so much, both of you, for joining us. I think this is a great way to wrap up the morning because we've talked a lot about collaboration, about obtaining data and what we can do with our data to protect the ice, the oceans and the forests. And it's just wonderful to wrap up with this session thinking about what we can do to tackle natural disasters and human-made disasters around the world, and particularly to end with this collaboration, because I think if there's one thing to take away from the morning, it is that all of these scientists that I've been talking to for the last few hours, they are all part of international collaborations. Nothing is done alone, and we need all of us to work together to think about the future of our planet and how to protect us. So this was a great note to finish our morning session on. I want to again just reiterate the positivity associated with each of the sessions that we've had so far. And just to remind you that there are things that we can all do. It's not too late, it's not all doom and gloom. There are things we can do to move forwards. And if you want to find more resources, then you can look for all of the people I've spoken to today, and there's more resources as well for your classroom that you can obtain. There's a link in the chat to that. So we can all help to save the planet moving forwards. Just also to remind you, the sessions are recorded, so again, if you missed anything from this morning, do feel free to catch up later. This session was protecting through space, but we have a number of sessions on this afternoon, protecting through science, technology, engineering, and maths. And that will be our sessions running through until 3 p.m. when we'll close our school sessions. Now, this afternoon's sessions are not just talking to scientists about the science they do, but also about how they got to where they are today. So if you're interested in getting involved in marine biology or protecting the forests, you'll be able to hear from and ask questions to experts working in this discipline about how they got there. So if it's not clear to you, how do I become a marine biologist, for example, you'll be able to ask all of those questions. So those sessions are going to be fantastic. Please do join us this afternoon, starting in about 10 minutes and running through until 3 p.m. Now, there is one more session, 3:30 until 4:30. It's STEM Club. It's an hour-long session with lots of different activities for you to join. So do stay on the line if you want to take part in STEM Club. Again, 3:30 until 4:30 UK time. Okay, thank you so much for joining me this morning. It has, as ever, been a great pleasure to talk with our experts around the world. I hope this galvanizes all of us into action around protecting our planet, and I look forward to hearing about the things that you have done and all of our scientists have done in 12 months' time when we continue our Protecting Our Planet series. Thank you so much.